Thank you very much.
Your screen. Okay.
Okay. Thank you. Thank you very much, Chairman, Professor Sabrina. Professor Sabrina is my co-supervisor when I study in University of Parma. Thank you. Good afternoon, everyone. My name is Li-Juan. I come from Taiwan University of Technology, China. Professor Li Pingguo is my PhD supervisor from Southeast University. Today, my topic is bond sleep behaviors between BFRP bar and the ecological high ductility concrete using the beam test. My report contains 4 parts. First, I will give a brief introduction. Second, I will present the experimental program, then the bond sleep behaviors, and last, I will give a brief conclusions. In the bridge engineering, there is a difference of elastic modulus between expansion joint and the concrete transition zone, resulting in an inconsistent deformation of the two kinds of materials. Thus, the expansion joint damages. Ecological high ductility concrete has an ultimate tensile strength of more than 0.5%. We will use the ECO HDC for the abbreviation. We can use ECO HDC material to cast the bridge deck link slab, replace the traditional expansion joint. Usually, we set the BFRP bar as the reinforcing bar. This is a picture show the bridge deck link slab. The link slab is in the negative moment zone and by the flexural tensile deformation. The bond behavior of BFRP bar embedded in ECO HDC can provide the embedment lag for the link slab. So beam test is conducted to analyze the bond sleep property between ECO HDC and BFRP bar in this study. This is a picture for the test setup. The beam specimen contains 2 half beams, and the BFRP bar is set in the flexural tensile zone. LVDT, this is LVDT. LVDT is set to monitor the sleep of BFRP bar. In this research, we consider 3 factors: diameter, embedment lag, embedment set as 3 diameter, 5 diameter, 7 diameter. Then we also consider the cover thickness. Then we go to the bond sleep behaviors. The filaments are related to the embedment lag, diameter, and cover thickness. When the embedment lag and diameter are smaller, the cover thickness is sufficient, so the filament is BFRP bar pulled out with specimen intact. For the BFRP bar diameter of 8 mm, when the embedment lag is less than 5 diameter, then the filament is BFRP bar pulled out with specimen splitting along the bar direction. When the embedment lag and diameter are larger and the cover thickness is insufficient, the filament is BFRP bar pulled out with specimen splitting along 2 directions, this direction and this direction. And then we also analyze the bond stress sleep relationship. We consider the embedment lag cover thickness effect. All bond response curves contain 4 stages. At first, we see the linear stage, then go to the non-linear stage. After the peak, the descending stage occurs and the residual stage. This is residual. This is also a residual stage. We analyze the effect of BFRP bar diameter on the feature values, such as the embedment lag, cover thickness. From the picture, we can see as the diameter and of BFRP bar increases, the peak pour out load increases for this picture and for this picture is an increase. while the bond strength decrease. This is a decrease trait. We also consider the embedment lag effect. As the embedment lag increases, the peak pull out load and free and slip increase. As this picture and this picture, it shows an increase trend, while the bond strength decreases. For the cover thickness effect, we can see as the cover thickness increases, the peak pull out load and bond strength and free and slip increases. Then, based on the analysis before, we propose the embedment lag. The two equations here, this is two equations, involve the size of BFRP bar as the diameter and the tensile strength of BFRP bar and ECO-HDC material. The slip coefficient, cover thickness coefficient, and the installation positive coefficient is constant. Based on the two equations, we choose the larger embedment lag as the desired value. And last, I will give a brief in conclusions. First, we consider the filaments. Filaments are related to the embedment lag, diameter, and the cover thickness. As the diameter increases, the peak pull out load of specimen increases, while both bond strength decrease. As the embedment lag increases, the peak pull out load and free and slip increase, while the bond strength decreases. As the cover thickness of bar increases, the peak pull out load and bond strength, free and slip of specimen also show an increasing trend. And last, we give the embedded lag of BFRP bar value when design the bridge deck link slab. Okay, my report is over time limit. If someone has interest with my direction, please contact me through the it's in my email address. Thank you for your kind attention. Thank you very much.